So this is lesson 7 in Algebra 2, percent and equations from geometry. All right, dealing with percent, we're just going to jump right down into example 7.1. And there are going to be two kinds of percent problems. In one type, the quantity is divided into two parts, and they have all these really weird pictures here, and I don't even understand the pictures, so I don't do my percent problems according to the way the book does, which when you have me for math very long, you'll hear me saying that a lot, and you're like, yeah, you never do things according to the book. Hopefully that's a good thing. So, anyway, and I'm sure you learned this in Algebra 1, that the word is means equal, and the word of means multiply. And life is really easy when you know that. And what number, that's your x. And that means what number. So if we look at example 17.1, it says 18 is 20% of what number? X. Okay, there's the equation. All right, one of the things about percentages, when something is in percent form, you cannot do the math. You have to change the percent to a decimal in order to do the math. So if you have 20%, you can't do anything with that until you change it to a decimal. So 18 equals 0.20x. Now we just divide by 0.20, 0.20, those go away. 18 divided by 0.20 is going to be 90. So x is 90, which means 18 is 20% of 90. All right. So the book says learning to draw these diagrams is very important. You know, not really thinking it is. You just need to be able to do the math, and you'll be fine with it. You don't need to draw the pretty pictures or anything to do this. Let's look at 7.2. 1,500 is, equal sign, what percent, what would be x, of 250? Okay, so here's the is, what of. Okay, so let's go ahead and solve this. So we're going to divide both sides by 250. And that's what? 4, 5, 6. So 6 equals x. All right, but the answer said what percent? This is not in a percent because it doesn't have this following it. So we need to change that to a percent. So in order to change to a percent, you take the decimal where it is now and move it over 2 place values to the right. So 6 is actually 600%. And we are done with those percentages. All right, equations from geometry. That's what we're going to look at in this second section. We can devise problems that let us practice working with geometric concepts and that also let us practice solving equations. Geometry, if you do geometry in this Algebra 1 book or Algebra 2 book and in the Algebra 1 book, you pretty much get a whole year of geometry in this class, so we do a lot of this. So if we have, and I'll just take a picture of example 7.3. So what they're asking us to do is find the value of x. So let's see, what do we know about triangles? We know that if we add up the angles, we get 180 degrees. So if I took 2x plus 2 plus I'd get 180. Well, let's take the parentheses off, and rather than me rewrite everything, I'm just going to take them off. I don't know why sometimes this eraser works fine and other times it doesn't. All right, now we're going to add like terms. 2x, 7x, 6x gives me 15x. So I can get rid of those. Now I'm going to add 2, 18, and 10. Equals 180. Subtract 30. Subtract 30. 15x equals 150. Divide by 15, divide by 15, x equals 10. That is not what I'm looking for. Oh, I guess it is. I was going to say, I thought I was looking for the angles here. So you'd take 10 times 2 is 20, plus 2 is 22. They don't want the degrees, they do want x. So at this point, we're done. They don't want us to go on any further here. All right, let's look at 7.4, and they give us another groovy picture there, so let me get rid of this and take a picture. Okay, something to note here. See these little arrows here? Those are symbols to tell you that all the other lines with those little arrows are parallel. So that just tells you that they'd never cross each other. All right, so what are they doing? They're asking us to find out what x is. So what do we know? We know that this one and this one are alternate exterior angles. No, because that's exterior and that's interior, so that doesn't work. But we do know that this one is the same as this one right here, and this one is the same as this one right here, and this plus this is 180, so therefore this plus this is 180. Wow. So I kind of went round and around in order to find that, but I do know that 4x plus 33 plus 3x, which is this one and this one, added together gives me 180. So that and that is 7x. Subtract 33 from both sides, goes away. Equals 147, divided by 7, divided by 7, those go away. X equals 147 divided by 7, which is 21. So x equals 21. Not a problem. All right, last one we're going to do is 7.5 example. Okay, so what do they say? The measures of angles A, B, C, and D are in the ratio of 1 to 2 to 4 to 2. All right, what that means is this is A, B, C, whoops, B, C, and D. I don't know why that doesn't draw very well up there. All right, that being the case, A, whatever A is, B is going to be double, C is 4 times, and D is double. Okay, so if A is, the degree of A is x, then B then would be 2 times x, C would be 4 times x, and D would be 2 times x. So these ratios just mean if that's 1, this is twice, this is 4 times, and this is 2 times. So when we do that, we have a 180 degree angle right there. So if I put a plus here, plus, plus, I'm going to get 180. So let's go ahead and add all those up. 3 and 4 is 7, plus 2 is 9. 9x equals 180. Divide by 9, divide by 9, x equals 20. Or if you're German, 20. And so then we can determine what all of these angles are. If x is 20, or if A is 20, B is 40, C is 80, and D is, whoops, 40. So if we add all those up, 60, 140, 180, we have a straight line. So there we go. That should be it.